Gazing upon a clear night sky, we are greeted by a celestial tapestry of twinkling stars. These stars, scattered across the vast expanse, are more than just distant points of light. Each point of light represents a distant sun, a beacon of energy and life in the cosmos, many of which are far larger and more powerful than our own. These stellar giants dominate their regions of space, influencing the formation of planets and other celestial bodies. Among these stellar giants are red giants, massive stars that have entered a new phase of their existence. These cosmic embers represent a fascinating stage in a star's life cycle, where the star expands and cools, taking on a reddish hue. Red giants are not merely larger versions of our sun, they are stars undergoing a dramatic transformation, a metamorphosis that changes their very nature. This transformation marks a critical turning point in a star's life, as it exhausts its nuclear fuel and begins to shed its outer layers. This shedding process leads to the creation and dispersal of vital elements throughout the cosmos, elements that are essential for the formation of new stars, planets, and even life itself. Understanding red giants allows us to peer into the life cycle of stars, revealing the processes that govern their birth, evolution, and eventual demise. It also helps us appreciate the processes that led to the formation of the elements that make up our planet and even ourselves. The very atoms in our bodies were forged in the hearts of ancient stars. By studying red giants, we gain insight into the cosmic alchemy that has shaped the universe, from the smallest particles to the largest galaxies. Join me as we explore the fascinating world of red giants, delving into their mysteries and uncovering the secrets of these celestial titans. Together, we will unlock the secrets of these celestial titans, understanding their role in the grand tapestry of the universe. Stars, like our sun, are not eternal entities, they have a finite lifespan. Their story begins within vast clouds of gas and dust scattered throughout galaxies. These clouds, known as nebulae, serve as stellar nurseries, providing the raw materials for star formation. Within these nebulae, gravity draws together clumps of gas and dust. As these clumps collapse under their own weight, they heat up, forming protostars. The core of a protostar continues to contract and heat until it reaches a critical temperature, igniting nuclear fusion. This fusion process, converting hydrogen into helium, releases an immense amount of energy, marking the birth of a star. The newborn star, now shining brightly, enters the main sequence, a long period of stability and energy production. The vast majority of stars in the universe, including our sun, reside on the main sequence. This stage represents a star's adulthood, a period of stability where it fuses hydrogen into helium in its core. The duration a star spends on the main sequence depends on its mass. Massive stars burn through their hydrogen fuel much faster, leading to shorter lifespans. Smaller stars, like our sun, sip their fuel slowly, enjoying lifespans of billions of years. During its time on the main sequence, a star exists in a state of equilibrium. The outward pressure from nuclear fusion in the core balances the inward pull of gravity. This delicate balance maintains the star's size and luminosity for millions or even billions of years. Although the main sequence represents a long period of stability, it is not indefinite. Every star eventually faces a fuel crisis. Over time, the hydrogen fuel in a star's core begins to dwindle. As hydrogen depletes, the outward pressure from fusion lessens and the delicate balance between pressure and gravity is disrupted. The star's core, now primarily composed of helium, begins to contract under its own weight. This contraction causes the core to heat up even further. Meanwhile, the outer layers of the star, still rich in hydrogen, begin to expand outward, cooling as they do so. This expansion and cooling cause the star's surface temperature to drop, shifting its color towards the red end of the spectrum. The star is now evolving into a red giant. Section 5. Red Giants, Stellar Expansion and Transformation. As a star transitions into a red giant, its size increases dramatically. Our sun, for instance, will eventually swell to engulf the orbits of Mercury, Venus, and possibly even Earth. The core of a red giant continues to contract and heat up. This intense heat triggers new fusion reactions in the outer layers where hydrogen is still abundant. These shell-burning reactions release even more energy, further fueling the star's expansion. The evolution into a red giant marks a dramatic turning point in a star's life. It is a period of immense change, both internally and externally. setting the stage for the creation of heavier elements. Section 6. The stellar crucible, forging heavy elements. Red giants are not only characterized by their size and reddish hue, but they also play a crucial role in the cosmic life cycle. These massive stars act as cosmic crucibles, where the most fundamental processes of the universe take place. Within the intense heat and pressure of a red giant's core, heavier elements are forged through nuclear fusion. The helium ash left over from hydrogen fusion begins to fuse, creating carbon and oxygen, essential building blocks of life. In more massive red giants, even heavier elements, such as neon, magnesium, and silicon, are produced. These elements are created through a series of complex nuclear reactions, each step building upon the last. This chain of nuclear reactions continues, producing a variety of elements that are essential for the universe. These elements, forged in the heart of dying stars, are essential for the formation of planets, moons, and other celestial bodies. Ultimately, these elements are crucial for life itself, forming the very foundation of our existence. The carbon in our bodies, the oxygen we breathe, and the iron in our blood all have their origins in these ancient stars. These elements were created billions of years ago within the cores of ancient red giants, long before our solar system existed. The story of these elements is the story of the universe itself, a tale of creation, destruction, and rebirth that spans billions of years. Section 7. The fate of red giants, from planetary nebulas to stellar remnants. The life of a red giant is finite. These stars, which have expanded to many times their original size, are in the final stages of their evolution. They have burned through the hydrogen in their cores and are now fusing helium and other heavier elements. Eventually, a red giant will exhaust its nuclear fuel, leading to its demise. This process is inevitable and marks the end of the star's ability to sustain nuclear fusion in its core. The exact fate of a red giant depends on its mass. Stars come in a variety of sizes, and this diversity plays a crucial role in determining their ultimate destiny. Low and medium mass stars, like our Sun, will eventually shed their outer layers into space. This shedding process is a gentle one compared to the more violent ends of more massive stars. This ejection of material creates a beautiful expanding shell of gas and dust, known as a planetary nebula. These nebulae are often observed in stunning detail by telescopes, revealing intricate patterns and colors. At the center of the planetary nebula lies the remnant core of the red giant, a white dwarf. This white dwarf is the leftover core, no longer undergoing fusion but still incredibly hot and dense. White dwarfs are incredibly dense objects, about the size of Earth, but with a mass comparable to the Sun. Despite their small size, they contain a significant amount of mass, making them one of the densest forms of matter in the universe. They will slowly cool over billions of years. As they cool, they will fade, eventually becoming cold, dark remnants known as black dwarfs, although the universe is not old enough for any black dwarfs to exist yet. More massive red giants face a more violent end. These stars, much larger than our Sun, have a different fate awaiting them. They undergo a spectacular explosion known as a supernova, briefly outshining entire galaxies. This explosion is one of the most energetic events in the universe, releasing an immense amount of energy. The core of the supernova remnant can collapse further, forming either a neutron star, an even denser object than a white dwarf, or a black hole, a region of space-time where gravity is so strong that nothing, not even light, can escape. These remnants are the final stages in the life cycle of the most massive stars, leaving behind some of the most fascinating objects in the cosmos. Section 8. Our Sun's Destiny. A red giant in the making. Our Sun, a yellow dwarf star, is currently about halfway through its main sequence lifespan. In approximately 5 billion years, it will exhaust its hydrogen fuel. At this point, it will begin its transformation into a red giant. The Sun will expand dramatically, engulfing the orbits of Mercury and Venus. Earth will become uninhabitable as the Sun's intense heat boils away its oceans and strips away its atmosphere. Eventually, the Sun will shed its outer layers, forming a planetary nebula. At the center of this nebula will lie the Sun's remnant core, a white dwarf. The white dwarf will slowly cool over billions of years, eventually fading into a black dwarf, a cold, dark object no longer emitting light. Section 9. Conclusion. The enduring legacy of red giants. Red giants, though representing a relatively short stage in a star's life, play a vital role in the evolution of the universe. They are responsible for creating and dispersing the heavy elements that are essential for the formation of planets and life itself. Their spectacular deaths, whether through the creation of planetary nebulas or the violence of supernovae, enrich the interstellar medium, providing the raw materials for future generations of stars and planetary systems. As we gaze upon these cosmic embers, we are reminded of the interconnectedness of the cosmos. The atoms in our bodies were once forged in the hearts of ancient stars, linking us to these celestial giants across vast distances of space and time.